Welcome to our training on Zero Code Analytics. This initiative is led by the AFRO's Agri-Food Working Group, the African Federation of Operations Research. The Agri-Food Working Group promotes research in agri-food supply chains in Africa for improved data-driven decision-making and enhanced food security. The goal is to support academics and professionals of logistics and supply chain fields. I'm Ali, a researcher of operations research. Today's lesson will cover a simple problem that chooses the quantity to produce of two products. First, we will transfer the word problem into a mathematical optimization problem. Then we will go from the mathematical optimization model to the solution format in Excel. We will then enter it into Excel's solver and finally interpret the solution. This is a weekly decision-making problem. Given limited resources, we would like to determine the production schedule of two computers, Disk Pro and Portable. The profit that we want to maximize for each is $50 per unit of Disk Pro and $40 for Portable. Production time for each is 3 and 5 hours respectively. The production manager checks and finds only 20 screens available for Portable, which means he can't produce over 20 units this week. Warehouse capacity also constrains the production as it has a total of 300 square feet. The Disk Pro and Portable take 8 and 5 square feet space respectively. First step to model the problem is to determine the decision variables. That is simple here. It is production units of each. We call them X1 for Disk Pro and X2 for units to produce of Portable. Next, the objective here, given the profit of each, is to maximize the profit of each. Thus, maximize 50x1 plus 40x2. Next, we set the constraints as listed as per our problem. We had assembly time and warehouse constraints as well as constraints on production of Portable units. So 3x1 plus 5x2, meaning time to produce each unit of each. Each unit of each is less than or equal 150 total assembly time. For each 1x1, it will take one of the available 20 screens. This is the second constraint. 8x1 plus 5x2 is the space each product takes, which must be less than or equal 300. Finally, we set the direction of search algorithm or solution space to be positive for both decision variables. The objective function, constraints, and decision variables are all entered in Excel Solver. See previous lesson on Excel Solver for installation. The objective function is set to maximize, and objective formula cell is selected. The constraints with direction less than or equal are set per their formula and the right-hand side parameters, which can be changed each week as per availability of resources. Finally, decision variable space is also indicated. Note we are using simplex here, so we select the simplex method. Simplex method is the most widely used to solve such mathematical optimization models. Other programming techniques can be used as well. The problem is entered into Excel similarly to the way it was modeled. We create a column per variable with an aggregation left-hand side equation, and the right-hand side values are also added. Notice objective value does not have a right-hand side. We try to maximize the left-hand side value of it in this case. The coefficients go beneath each other and the equation set in the next cell with the right-hand side specified. Solution cells starting with random variables for x1 and x2 are indicated for the model to be used. Notice that the left-hand side is the product of the coefficients and the variable values, as you can see in this formula. Again, the inputs to the model are the objective function equation, the decision variables random set value, the left-hand side equations, and the right-hand side values. The solution thus can be found with optimal profit of 1980, the values of x1 and x2 in the second table of 30 units and 12 units, of 20 units of this pro and 12 units of portable. And we can see from the non-binding constraints that we have a surplus of 8 screens, which can be carried on to the next planning schedule. Thank you for choosing to learn with us. Stay tuned for more on zero-code supply chain analytics.